For the first lesson here of chapter 12, we're going to be taking a look at arithmetic sequences. This whole chapter revolves around a handful of formulas that we're going to be using, so you always want to make sure that you have your formula packet handy this chapter so that you're familiar with what those formulas look like. But there's two main types of sequences that we deal with. One is arithmetic and the other is geometric. So the key to arithmetic sequences is that in the pattern, you are always adding to get the next term. So if you take a look at the one we're going to look at here in just a minute, you should notice that I'm always adding the same number every time to get the next term in the sequence. So anytime it's adding, it's arithmetic. If you're ever multiplying to get the next term, it's geometric. And so those are the two sequences we're looking at. If you take a look at the formula packet, right below percent error, this is percent error is the one that we did in the very first unit. Right below that, you get 5 formulas that we need for this chapter. So all 5 of these are for this chapter. So here's the one we're looking at right now in this lesson, is the nth term for the arithmetic sequences. So there's 2 for arithmetic, there's 2 for geometric, and then there's a compound interest formula that we're going to look at. But even the compound interest formula is really just a geometric pattern. It's really the same formula that you're seeing right here, just with some different letters thrown in. So, but anyway, so for the one we're looking at right now, here's what we have. So a couple keys on this one. The u sub 1 is your first term. The n is the term number, so first term, second term, third term. D is the common difference. So the common difference is whatever is being added every time to get the next term. So we never look at it as subtraction. If the numbers are decreasing by 10, we wouldn't say we are subtracting 10. We would say we are adding negative 10. And so negative 10 would be your common difference. For u of n is a value of a term. So here's the key to this one is whatever this value is, this is the term number that goes with it. So if we said something like the fourth term is 8, well, then this would be a 4, right? The fourth term is 8. 8 would be the value of that fourth term. So those guys always go hand in hand. So that's the formula we're looking at for this lesson. So to make a little change, our old books used an A. We now use a U. So that's what's going on there. Anyway, here's an example of an arithmetic pattern or an arithmetic sequence. So can we recognize that it's arithmetic? Yeah, of course, because we are always adding the same number every time to get the next term in the sequence. What is that term that we're adding? 5, right? So between every 2 terms, we are adding 5 to get the next term. There's going to be a couple cases where the common difference is a little harder to recognize because it's a fraction or a decimal, whatever. Maybe we're getting into some bigger negatives, whatever the case might be. There is a little trick to coming up with the common difference. If it's not as easy to recognize just by looking at it, because you are always adding every time to get the next term, if you want to spot the common difference, just take any 2 consecutive terms and subtract backwards. So I could either do 13 minus 8, and that would give me my common difference of 5. I could do 8 minus 3. I could do 3 minus negative 2. Any way you want to look at that, but you can always subtract to the left to get your common difference. The general term or the rule, either way you want to say that, is just a description of the pattern. So notice that we leave n as n to get the general term. So this would apply to any term number, not just a specific term number, but to any term number. So if we plugged in negative 2 for the u of 1, so right here I'm plugging these guys into our formula right here. So we're plugging negative 2 in for u of 1. We're plugging a 5 in for the common difference, and that's all we need to get the general term. So if we do a little cleanup on this, we're going to distribute the 5. We're going to combine like terms, and this would be the simplest way we could look at the general term for that sequence. But now it can be used to find any value you want. So now if you said, okay, well I want to know the 20th term, well I'll just stick a 20 right there in for n, and you can get the value of the 20th term. So, for example, what is the 20th term of an arithmetic sequence? So they're giving us the first term is 6, the common difference is negative 2, so we're just going to take advantage of the formula from up above, plug in some numbers. So when they say the 20th term, so here's the little notation that we would use to identify the 20th term. So u of 20 or u sub 20. So we're going to plug in a 1 for u, or sorry, 6 for u of 1. We're plugging in a 20 for n since we're looking for the 20th term. Plugging in -2 for the common difference. And if you clean that up properly, you should get -32 is the value of the 20th term. Common difference, when the 15th term is 45 and the first term is -11. So again, we're just taking advantage of the formula from up above. This is kind of the way this whole chapter goes, is just making proper use of formulas. So looking up above, so there was a connection that I described at the beginning of this lesson for that formula. And that's where we said, see if I can get this all on the screen here for you at the same time. So we said, whatever that term number is, this is the value of that specific term. So in this problem we're looking at right now, when they say that the 15th term is 45, they're saying the 15th term has a value of 45. And so we're plugging those in for those two locations. They told us the first term was -11, so we're plugging that in here. So notice that if we sub in all those numbers, that leaves us with one unknown, which is the common difference. And so we can now just solve that equation for D, and we come out with a common difference of 4. Arithmetic sequence, so if we know the first term of 120, and we know the 10th term of 57, find the 15th term. So similar beginning on this one. We know the first term is 120, so we're plugging that in for u of 1. The 10th term is 57. So again, remember the connection in this formula. Whatever this term number is, this guy is the value of that term. So they said the 10th term is 57, so we're subbing in those numbers there. Just like in example 3, we're going to solve for the common difference and get -7. But notice that this particular question was asking for the value of the 15th term. That's another big important thing to this chapter, is always make sure you answer the question, because some questions can look pretty similar, but in the end they're asking for something different. In example 3, they wanted the common difference, and so we were able to stop here. But in example 4, they want something more. They want the 15th term, so we got to keep going until we answer that question. So we know the common difference is -7. So we go back up to the main formula. We're looking now for the 15th term. So we have our first term. If we're looking for the 15th term, then we're going to plug in a 15 for n. We got -7 for the common difference that we just figured out in the first step. And now we can clean all that up to get the value of the 15th term. All right, last example for these notes. So right here, again, arithmetic sequence. Sometimes these get abbreviated as AP, like arithmetic pattern. Anyway, arithmetic sequence. So we got the 7th term of 16.5. We got a 12th term of 24. And we're looking for the 25th term. So we're going to take advantage of what they gave us. One thing so we'd recognize on this one is that we have two unknowns. Normally within our formula, in order to do any of what we've done so far, we needed to know two important keys, and that was the first term and the common difference. Notice in this problem, we don't know either one of those, so all we know is the 7th term and the 12th term. So in this case, we have two unknowns, which means we have two equations. So anytime you got two unknowns, it would take two equations or a system of equations in order to solve it. So we're going to create a system of equations, and then we can use elimination to solve our system of equations. So in this one here, one equation that we're going to work with is for the 7th term. So if we know the 7th term is 16.5, so right here is our first setup. Let me show the formula really quick so I can explain. So they said the 7th term was 16.5, so I'm putting a 7 right there. I'm putting 16.5 right there. Obviously, if I'm going to put a 7 right there, well, 7 minus 1 is 6. So that's where you're seeing the 6 come into play, because we did the 7 minus 1. For the second equation, we have a 12th term of 24. So very same idea. I'm putting a 24 in for the value. I'm putting a 12 in for n, so 12 minus 1 is going to give us the 11 that you see here. But we don't know the first term, we don't know the common difference, so I'm leaving those alone for now. But here is our system of equations, and we're just going to use elimination simply to solve. So I'm just going to subtract those two equations straight down. So 16.5 minus 24 is negative 7.5. u1 minus u1 is 0, so those guys get eliminated. And then 6d minus 11d is negative 5d. And if I just divide the negative 5 over to the left, I get my common difference, which is 1.5. Decimals are okay. The only time you have to use fractions is if you get like an ongoing decimal. You never want to round anything for these problems. You always want exact numbers. So if you ever have to round it, don't round it, just use a fraction instead. But this is not rounded. 1.5 is exact, so we're good there. So if my common difference is 1.5, I can take that, pick either equation, sub your 1.5 in for d. So if I were to just pick the top equation, replace my d with 1.5, I can now solve that for the first term, and you'd come out with 7.5. So we now have our two keys. We know our common difference. We know our first term. Now we can answer the question that was being asked, which was find the 25th term. So now we're going to go up, again, formula one more time. We're looking for the 25th term. We can now sub in our u of 1. We're looking for the 25th term, so that goes in for n. We know our common difference of 1.5, so you clean all that up, and you get your 25th term, which is 43.5.